Nigeria, the quest for clean water. Did you know that over 57 million Nigerians don't have access to safe water? That's more than the entire population of Canada. The population of Nigeria is about 190 million people, so in other words, 30% of the population doesn't have safe water to drink, which is ridiculous. Not only that, but 60,000 children in Nigeria under 5 years old die annually from diarrheal diseases caused by poor water and sanitation. Now, we weren't aware of some of these statistics until only recently, and here's how it began.
We all went on a vacation to Nigeria. As we toured some of the known landmarks in Nigeria, we stumbled across a village. Nigeria had many more villages than cities, so it wasn't much of a surprise. But when we examined the village a little closer, we saw that there were some hard-working Nigerian children walking back to their village with containers full of water on their heads. These poor souls were supplying water for the entire village to drink and survive. After seeing the children, we quickly became curious about where its water was actually coming from, so we walked into the direction of where the children came.
A kilometer or so later, we found it, the place where the water was coming from, and we were shocked. It was a filthy river with opaque brown water that could not be healthy for a human being under any circumstance. To make matters worse, we saw some of the children sipping up some of the grimy water from the river just because of how thirsty they were. We couldn't bear this sight, so we asked our tour guide on why they were drinking this, and he simply replied that they had no other choice. The Nigerian government could hardly give a damn because they were blowing money on road infrastructure. We became furious, and we decided there had to be a change. The villages in Nigeria couldn't go on like this. So after weeks of research and theory crafting, we came up with a solution.
Our solution to the lack of potable water in Nigeria is broken into 2 parts. The first part revolves around acquiring the water. We propose that water wells should be drilled in villages of Nigeria. These water wells can help to acquire water that is of far better quality than the water that lies in the polluted rivers. Groundwater is free of disease-causing organisms and virus-inducing bacteria, as well as many other contaminants that would be found in water exposed to open nature. Not only that, but water wells are relatively cheap and efficient as well. Just one water well can support an entire village of over 2,000 inhabitants and costs about $8,000 on average. The cost can vary, however, between $500 and $50,000, depending on depth to the water, soil toughness, etc.
The best method of creating water wells is mechanical borehole drilling, which involves using a large drill to create a hole into the ground, usually around 30 feet deep. The wells are then reinforced with concrete to wall off the dirt, and a metal seal plate is placed on top of the well to prevent the groundwater from being contaminated. The wells also have a mechanical water pump built in, so that the water can be safely acquired without much physical effort.
Now, even though groundwater is relatively clean, it still requires some filtering as it is not 100% drinkable. This leads us to the second part of our plan, which is cleaning the water itself. On the pump of the water wells, slow sand filters will be attached to filter the water as it is acquired. These filters keep out many contaminants such as sediment and elements like arsenic and iron. They also significantly reduce any odors in the water and improve its overall taste. Slow sand filters are made with layers of sand and gravel. On the top layer of the sand, a biological layer made up of microbial bacteria is grown, called smutzdek, where particles of foreign matter and biological matter is absorbed from the water.
One of the best things about these filters is that they are quite cheap, as the materials can be found very easily and constructing one isn't too difficult either. To create an automated filter, it costs around $600. The only downside of a slow sand filter is that, like its name suggests, the rate at which it filters water is kind of slow. It filters approximately 250 liters of water per hour per meter squared of sand. This shouldn't pose much of a problem, as it is more than fast enough to get water for everyone in the village throughout the day.
Here's a quick rundown on how the filter actually works. The contaminated water comes in through the opening valve, where it then passes through the smutzdek, removing all of the biological matter from the water. It then goes through the sand and gravel, where sediment and metals are cleared, and it finally goes into the underdrains, where it flows to a tank of water from which it can be obtained.
So why will our plan work to effectively reduce water poverty in Nigeria? There are multiple reasons. Our plan is very cost efficient compared to some other water treatment techniques used in other countries. So the President of Nigeria is more likely to help us put our plan into place. Also, the method of acquiring the water isn't very hard for villagers to operate, so it would be easy to teach them. Moreover, water wells are safe, so even kids would be able to operate them. Finally, water wells can last almost 10 years before they need to be revised or replaced.
Our idea of effectively acquiring water through water wells and using slow sand filters has been thoroughly planned to adapt specifically to Nigeria's geography. The wells suited Nigeria far more than a desalinization plant because of its location relative to seawater. Also, the slow sand filters were used because UV, ceramic, and activated carbon filters require lots of energy and raw materials that cannot be found in Nigeria. The outcomes of combining these two relatively inexpensive methods help us provide safe, affordable drinking water to every village. After all, access to clean water is a human right, one that we take for granted.
Thanks for watching.